to another exciting episode of Count on Us, Reasoning and Sense Making. We are here to assist you today with understanding word problems and working through word problems. I am so excited that you chose to take a little bit of time out of your day to join us. So grab yourself a pencil and a piece of paper. Get ready to explore decimals and fractions and number sense, multiplication and division. You ready? Come on, let's go do some math.
4, 3, 2, 1.
Hey, Grade 3 scholars. Welcome back to Count on Us, Reasoning and Problem Solving Grade 3. This is Coach Young coming to you with another engaging math mini lesson. We are back for another week on air supporting 3rd through 5th grade math learning on Monday afternoons and 6th through 8th grade math learning on Wednesday afternoons. Both shows will air from 5 o'clock to 5:30 p.m., so make sure you and your friends tune in. Our show will focus on specific grade level standards and problem-solving strategies to develop you into successful mathematicians. So, let's get started. By the end of today's mini lesson, you will be able to say, I can use multiplication and division within 100 to solve word problems. Solving today's reasoning and problem-solving problem will be as easy as 1, 2, 3. Here are the steps we will follow as we solve today's problem. Step 1, we're going to read and understand the problem. Step 2, we're going to ask ourselves, what do we know that will help us to solve the problem? And step 3, we will solve the problem by doing the math. For the first read, I will read the problem to you. Then we will discuss what the problem is about. Zara buys 5 packages of orange juice boxes and 5 packages of apple juice boxes. Each package of orange juice contains 6 boxes. There are a total of 80 juice boxes. The first bullet says, find the total number of apple juice boxes. The second bullet says, what is the total number of apple juice boxes in each package? And the third bullet wants you to show your work or explain your answers. So let's think about what the problem is about. After reading this problem, I imagine Zara buying 5 packs of orange juice boxes and 5 packs of apple juice boxes. Each orange juice pack contains 6 boxes, and Zara has a total of 80 juice boxes. For the second read, I would like for you to read the problem along with me. Zara buys 5 packages of orange juice boxes and 5 packages of apple juice boxes. Each package of orange juice contains 6 boxes. There are a total of 80 juice boxes. Find the total number of apple juice boxes. What is the total number of apple juice boxes in each package? Show your work or explain your answers. Now I want you to think about what the quantities and units are in the problem. Quantities are the numbers and units are what's being counted. In this problem, we see a quantity of 5 that represents the number of orange juice packages. Another quantity of 5 that represents the apple juice packages. A quantity of 6 that represents the number of orange juice boxes in each package. And a quantity of 80 that represents the total number of juice boxes altogether. For the third read the problem to yourself one more time. Think about what's missing from this problem. It is important that you understand what the problem is about, as well as understand the quantities and the units in the problem before rushing to answering the question. Now that we have done that, what questions are we responding to that is given in the problem? Here are the questions I noticed. How many apple juice boxes are there? What is the total number of apple juice boxes in each package? This is a visual of the entire problem. This is the way your problem will look like virtually. You will be given a space to explain your work. You will also be able to enter equations in the space using the equation editor located on the right side of your workspace. You may also see a drawing box for you to model your work using the drawing tool. The questions we will be finding the answers for are: how many apple juice boxes are there? And what is the total number of apple juice boxes in each package? Now, what do we know that is going to help us solve the problem? We know that Zara bought 5 packages of orange juice boxes. Zara bought 5 packages of apple juice boxes. Each package of orange juice contains 6 juice boxes, and that there is a total of 80 juice boxes. Let's figure out how many apple juice boxes there are. In order to figure out how many apple juice boxes there are, let's figure out how many orange juice boxes we have. We know that there are 5 packages of orange juice and that each package contains 6 orange juice boxes. When I do the math and multiply 5 groups of 6 orange juice boxes, I get a total of 30 orange juice boxes. Now that I have a total of 30 orange juice boxes, I will subtract that number from the total of 80 juice boxes. Now that we have done the math, we now know that there are 50 apple juice boxes. So what is the total number of apple juice boxes in each package? We know that there are 50 apple juice boxes, and we also know that Zara bought 5 packages of apple juice boxes. As you solve this problem, it is important to label your work. Here we have 5 packages where we will divide the 50 apple juice boxes into. When we have finished dividing our apple juice boxes, we see that there are 10 apple juice boxes in each package. Written as a division equation, we have 50, the total number of apple juice boxes, divided by 5, the number of packages Zara bought of apple juice boxes, which gives us a quotient of 10, the number of apple juice boxes in each package. This can also be written as a multiplication equation. An unknown times 5 equals 50. And for this problem, we now know that the unknown number represents 10, the number of apple juice boxes in each package. As you are working on your math problem online, remember that your screen will give you a work area where you can type in your response, including equations using the equation editor. You may also see a drawing box to model your work in the space provided. Make sure to use that area to show all of the work you did to solve the problem. This allows anybody looking at your work to clearly see your understanding of the problem. Today, we read the problem for understanding, used what we knew, and solved the word problem that included multiple operations. What strategies did we use? We applied the 3B strategy, we visualized the problem, and we drew a model to solve for our problem. Now, you can officially say that you can use multiplication and division with N100 to solve word problems. That's it for today, third grade scholars. Our next segment will be for our fourth grade students. Until next time, stay safe, and we'll see you soon.
Good afternoon, fourth graders. I know you guys are ready to do some math today. Today we're going to be looking at a multiplication problem. And we know multiplication, we're multiplying factors by factors to find the product. Today we're going to be using a strategy called the area model. With the area model, you're going to be breaking down your numbers by their place value and writing them in expanded form before you start multiplying. Now, as we always do in math, we need to make sure that we are attending to precision. And in terms of today, when you find your partial products, you need to make sure you're adding up the partial products correctly. That means lining up all of your place values, your ones, your tens, and your hundreds to make sure that you're adding them up and attending to that precision so you do find that final product. So let's get into the problem today. Make sure you have your pencil and your paper ready so that you can follow along and complete the problem while we're working on it.
Welcome. Hopefully you enjoyed that introduction. But if you didn't, or you didn't catch it, my name is Coach Brenner, and I am so glad that you've joined us today. Fourth graders, by the end of today's lesson, you'll be able to say I can multiply multi-digit numbers using strategies based on place value and properties of operations, along with being able to say I can use equations, rectangular arrays, and or area models to show and explain how I multiply. Now, parents, this is also a good opportunity for you to see how these area models are used for multiplication based off of place value and not that standard algorithm that we might have used back when we were in school. So this is a great activity for not only students, but also parents. So stay tuned. So let's look at our area model. We're breaking up 54 times 78. So this model is going to help us find the result of this problem. All right. If you notice, we broke up 54 into 50 and 4, okay, by place value, tens and ones, and 78 into 70 and 8. So we broke that up into our tens and ones. And with the area model, you can see that we have these boxes for a rectangle inside of the area, which is going to find our partial products. So let's look at this. So here's our model. Our first partial product, we have 50 times 70, which is equal to 35 hundredths, or 50 times 70, which is 3,500. All right. So notice at the bottom of the screen, it shows how 54 was broken up into 50 plus 4, and also how 78 was broken up into 70 plus 8, and the numbers that we are multiplying. So 50 times 70, like I said, and now we move on to our next partial product. 50 times 8 equals 40 tenths, and 50 times 8 equals 400. So we multiply 50 times 8. All right, now we still have 2 more boxes to fill in our area model for our partial products. Up next is 4 times 70, which is 28 tenths, or 280. All right. Now, do we have another partial product to find out? Sure do. We have to multiply our ones together. So here we're going to multiply 4 times 8, which equals our 32 ones. All right. Now that we've done this, we can add up the partial products to get the final product. Now you might say, why do we need to find the partial products in order to get the final product? Well, one of the reasons is by breaking it up by place value, it really allows the student to see the numbers getting larger and also makes it a little bit easier when lining these numbers up by place value to make sure that you're adding up the correct digits. So if we look at what our partial products are, we have 3,500 plus 400 plus 280 plus 32. Now we're going to break up each place value. So how many thousands are there? Well, there's 3 thousands. So we can bring our 3,000 down. Next, what's the next place value? Hundreds. So let's look at the hundreds that we have. We have 500, 400, and 200. Now we can add these up a couple different ways. So we bring our 500, our 400, and our 200 down. And to make life a little bit easier, we can do 500 and 400 to get 900, and then we can add our 200 to get 1,100. Notice we've created another 1,000, but another way we could do this is also by bringing down the larger number 500 and then adding together 400 plus 200, which still gets us that 1,100. And like I said, remember, we have another 1,000 here. So let's keep that in our brain, in our memory, for when we're adding up our final product. Next, we've done our thousands. We've done our hundreds. What's the next place value? Tens, if you said that. All right, so the tens that we have are our 80 and 280 and 30 and 32. So we have 8 tens and 3 tens, which we're going to add up. So 80 plus 30 equals 110. So now we also have another 100 there. All right, so is there any place value that's still left? Yep, we have a 2, and you can see that down here at the bottom. So now, once we have those partial products, we add up all of the place values we have. We have our 3,000 plus 1,000, which equals 4,000. We also have 100 plus 100, which equals 200. And with our tens, we have 10 plus 30, which equals 40. Don't forget about our ones. We have 2 ones. Now, once you add all these up, you can line these place values up and you can see you have 2 ones, 4 tens, 2 hundreds, and 4 thousands. And that is how you can solve, using multiplication, strategy of the area model, double digit times double digit. So we found our partial products and then we added them together to find our final product.
Thank you guys for tuning in to another amazing edition of our Count on Us mini lesson for 4th grade. With multiplication, we know that your parents and even some of the teachers that are teaching learn it a different way with that standard algorithm, where you have to regroup, you might have to carry, they might use some different terms. With the area model, it takes away all those possible issues or problems. You break up the numbers with your expanded form, you multiply the numbers, so you're multiplying a tens by a tens, you bring your zeros down, right, because you're holding that place value, and then you add up your numbers, your partial products to get your total product. So for me, when I was in 4th grade classroom, I really pushed this with my students to make sure that they understood how simple this can be, along with helping them understand the true meaning of place value. Because if you carry something over or you're regrouping, you're not just adding a 1 or you're not just adding a 7. That 7 may be 7 tens or 7 hundreds. So that's where breaking it down in terms of using the area model like we did today, it really allows students to see how place value really changes the understanding of what the number is, what the digit's worth. A 2 could be worth 2 ones, 2 tens, 2 hundreds, or 2,000s. So that really comes into play when using the area model. Thanks for tuning again to another edition of Count on Us for 4th grade. Stay tuned. 5th grade is coming up next. And you 4th graders, you might as well stay tuned. Check out what 5th graders are doing in your next video.
Welcome to Count on Us, Reasoning and Problem Solving for Grade 5. I'm Coach D, and I'm so excited that you're here today. I hope everyone is having an amazing week. Let's get started. Today, reasoning and problem solving will be as easy as 1, 2, 3. Here's our steps. 1, read and understand the problem. 2, ask, what do you know that will help you to solve the problem? And 3, solve the problem by doing the math. Last week, we answered the question, what is the total number of toy animals in one crate? That was 31,104. Today, we will solve Part B. Part B. One bag of toy animal weighs 12 ounces. What is the total weight in ounces of the bags of toy animals in one crate? What do we know? We know the problem is asking us for the weight in ounces of the bags of toy animals in one crate. We know there are 48 bags in one box. There are 18 boxes in one crate. And each bag of toy animals weighs 12 ounces. In Part B, we're looking for the total weight in ounces of the bags in one crate. In one crate, there are 18 boxes with 48 bags in each one of them. First, we must figure out how many bags we have altogether. Once we know that, then we can figure out how much the bags in one crate weigh. That's where we ended last week, and you were supposed to complete Part B. Let's do the math together now. So we have 48 times 18. Let's estimate to start. 48 is close to 50, and 18 is close to 20. So we're going to use 50 times 20, which equals 1,000. So 1,000 is our estimate for this problem. Let's start with the area model. I decomposed 48 into 40 plus 8 and 18 into 10 plus 8. Let's set up our problem. Here's 40 and 8, and we're going to represent 10 and 8 on the top. This first area is 40 times 10, which equals 400. This area represents 8 times 10, which equals 80. This area is 40 times 8, which equals 320. And our last area represents 8 times 8, which equals 64. Now that we have all the partial products, let's add them together. In the ones place, we have 0 plus 0 plus 0 plus 4, which gives us 4. In the tens place, we have 0 plus 2 plus 8, which gives us 10, plus 6 gives us 16 tens. The 6 goes down, and the 10 tens are regrouped to 100. In the hundreds place, we have 100 plus 400 plus 300, which gives us 800. 864 is close to our estimate of 1,000, so our answer is reasonable. There are 864 bags in one crate.
Now that we know that there are 864 bags of toy animals in one crate, we can multiply that by 12 ounces. That's going to help us to see how much the bags of toy animals weigh in one crate. Let's start with an estimate. 864 is close to 1,000 and 12 is close to 10. So the equation we're going to use is 1,000 times 10, which gives us 10,000. Our answer should be close to 10,000. Next, I decompose 12 so I can have 864 times 10 plus 864 times 2. 864 times 10 gives us 8,640. Because we have a base 10 number system, when we multiply a number by 10, the digits in the product shift one place to the left. To multiply 864 times 2, I decompose 864 by place value. 800 times 2 is 1,600. 60 times 2 is 120. 4 times 2 is 8. I combine those partial products to get 1,728. I took 8,640 plus 1,728 to give me the final product of 10,368. Let's see how the partial product algorithm is connected to the standard algorithm. In the standard algorithm, we're going to start by multiplying 864 times 2. 4 times 2 is 8. 60 times 2 is 120. And 800 times 2 is 1,600. Plus the 100 we regroup gives us 1,728. Next, we're going to multiply 864 times 10, which is 8,640. And just like with the partial products, we're going to add together 1,728 plus 8,640 to get 10,368. Both the partial product algorithm and the standard algorithm can be used to multiply. So our answer to 864 times 12 is 10,368. The bags of toy animals in one crate weighs 10,368 ounces. And that's our answer to part B. Now we have time for one more problem. Again, we're going to start with reading the problem. Josh biked 1 1/3 miles to school. Callie biked half mile to school. The fraction strip diagram shown can be used to find how many more miles Josh biked than Callie. What is this problem about? It's about Josh and Callie riding to school. For the second read, we're going to read it one more time, and we're going to focus on the quantities and the units in the problem. Remember, quantities are the numbers and units are what's being counted. Josh biked 1 1/3 miles to school. Callie biked half mile to school. The fraction strip diagram shown can be used to find how many more miles Josh biked than Callie. What are the quantities and units in this problem? 1 1/3 miles, half mile. For the third read, you're going to read the problem to yourself. What's missing? The question is missing. It's important to understand first what the problem is about, and second, understand the quantities and the units in the problem before we solve. So what problem are we going to solve? 1. How many more miles did Josh bike than Callie? Explain how the diagram can be used to answer this question. And 2. What is the total number of miles Josh and Callie biked altogether? Explain how the diagram can be used to find the total number of miles Josh and Callie biked altogether. What do we know? From the problem, we know that Josh biked 1 1/3 miles to school. Callie biked 1/2 of a mile to school. We also know that the diagram we have to use is partitioned into 6. Now let's do the math. Part A says, how many more miles did Josh bike than Callie? Which means we are comparing the distances, so I can subtract to find the difference. We can start by decomposing 1 1/3 into 1 plus 1/3. Before adding and subtracting fractions, we must have common denominators. We can replace the unlike denominators with equivalent fractions with the same denominator. Let's ask ourselves how many sixths are equivalent to 1 whole, 1/3, and 1/2. Look at these fraction strips. A whole partitioned into 6 equal parts shows that 6/6 is equivalent to 1 whole. Thirds have 3 equal parts to make 1 whole, and it takes 2/6 to be equivalent to 1/3. 3/6 is equivalent to 1/2 because 3 is half of 6, and fractions equivalent to 1/2 follow that pattern of the numerator being half the denominator. So now that we have 6/6 plus 2/6 equals 8/6, we subtract 3/6 from 8/6 to get 5/6. Josh biked 5/6 of a mile more than Callie. Now we must explain how the diagram can be used to answer this question. To find out how much further Josh biked, I need to subtract 1/2 from 1 1/3. 1 1/3 is equivalent to 8/6 on the diagram, and 1/2 equals 3/6. I can cross out 3/6 on the diagram from the 8/6, which gets me back to the first fraction strip at 5/6. So Josh biked 5/6 miles farther than Callie. Part B says, what is the total miles Josh and Callie biked all together? So I know I can add the miles together. To add, we must have like denominators. I use the same equivalent fractions from Part A. 1 whole is equivalent to 6/6. 1/3 is equivalent to 2/6. And 1/2 is equivalent to 3/6. 6/6 plus 2/6 equals 8/6. 8/6 plus 3/6 equals 11/6, or 1 5/6. Josh and Callie biked 1 5/6 miles altogether. Now let's explain how the diagram can be used to find the total number of miles Josh and Callie biked altogether. Here's our explanation. To find the total distance biked altogether, I need to add. Josh biked 1 1/3 miles, which is the same as 8/6, or 1 2/6 miles. On the diagram, this is 1 full fraction strips for the whole number, plus 2/6 for the fraction part. Since the mixed number, 1 2/6, is the same as 8/6, I labeled 8/6 with J's to represent Josh on the diagram. Callie biked 1/2 of a mile, which is the same as 3/6 mile. I labeled 3/6 on the diagram with C's to represent Callie. 8/6 plus 3/6 equals 11/6, and that's equivalent to 1 5/6. Wow, we've done a lot of reasoning and problem solving today. Let's review. First, we read the problems for understanding. Second, we used what we knew to solve. And third, we did the math. We used pictures, diagrams, and models to help us visualize the problems. In the first problem, we connected the partial products algorithm and the standard algorithm. In the second problem, we used equivalent fractions to find common denominators in order to add and subtract fractions and mixed numbers. Well, that's our show for today. We hope to see you back next week. Remember, you can always count on us. Bye.
Hello and welcome to Count on Us. This is Coach Brenner, and over the next couple weeks, I'm going to be showing you guys a little bit of stuff about MCAP assessment. Do you remember that? I think you do, but the main thing is I'm going to be helping you as parents at home to help support your child. Students, this might be helpful as well. We're going to be looking at the MCAP website itself. We're going to be looking at some tools, how to access the practice tests, along with other little tips for test taking. Make sure all your materials are ready, since we know some of you guys are going to be taking this at home. Distance learning hasn't been the easiest on any of us over the last year, but hopefully this video will help, especially those third graders who will be taking this assessment for the first time. I feel like they're a little bit more prepared than they would be if you weren't watching this. So parents and students, please take some notes, pay attention, make sure that you're listening, you're tuning in over the next couple weeks, because Coach Brenner is going to be here to help support you and make sure you and your child are ready when it comes to taking the MCAP assessment.
So first, you're going to want to know how to access the MCAP website. You can type into your search bar MCAP and it'll pop right up, or Maryland Comprehensive Assessment Program. Or if you type right into your URL, you can type support.mdassessments.com. Again, you can type in support.mdassessments.com. And once you're there, it's going to take you right to this page. There are a bunch of tabs up here. You can peruse them and go through them at your own leisure at home. But the main thing you're going to want to get to is, one, make sure that your technology set up so that the computer at home can properly access TestNav, which is the site that your students will be going to take the MCAP. And the one that we're going to be looking at today, and this is just that beginning stage, is the test preparation. So when you click here, there's going to be a tab for tutorials, and this is something that you can go through. Just make sure that there's a TestNav tutorial. There's printable ones you don't necessarily need, but there's a lot of options here for you as a parent to make sure that you understand everything that your student has to do in order to be successful with taking the computer-based MCAP. So I'm going to go back to home. Once I go back to home, I'm going to go back to this test preparation. All right, I'm going to click that down button again. Now, I already clicked on tutorials. I'm going to click on practice tests. And this is something as a parent will allow you to see what your students have to be able to do in order to do well on this test, and at least be able to navigate through the test easily. Especially those third graders, like I mentioned before. This is the first time they're taking this assessment. Fourth graders and fifth graders have taken it before, but they still need that practice and reminder of how to access. Now, when you're on here, all the different tests that your students will have to take, the English, language arts, your math, MISA for those fifth graders, social studies for middle school as well. So if you have other children, this is a website that they can all get on to practice. But since this is Count on Us, and we know we're focusing on math, Let's look at math. Now, all different grade levels. We have grade 3 all the way up to algebra 2. Let's look just at grade 3 to see how we can access this. So you're going to click right on grade 3. They give you two different columns, computer-based test along with paper-based test. We are going to look at the computer-based test. Now, one of the great things that you can also use at home is that there's a practice test answer key. This is a way that you can assess your children at home if the scoring isn't necessarily done right away. Now, the computer can score certain questions and let your child know at the end if it's correct, but some of those other questions where they're going to have to explain their answers and show their work, those are the ones that they're not going to be able to get scored online. Now here we know that there is some different versions that we can have here. The TTS, what this stands for is text to speech. So if your child gets text to speech, they're allowed to do this. This is where the question will be read to them. But since this is that introduction, let's just take grade 3. We're going to click on it. It's going to take you right to this page. All right, so once you choose your grade level, and we clicked on grade 3, it's going to give you an overview of what your grade 3 or grade 4, grade 5 questions are going to be broken up into. So section 1, we can see that there's 12 questions. Section 2, there's 6. Section 3, there's 11. Section 4, there is 6 questions as well. So this is just an overview. Remember, this is a practice. This is not the exact test that your students will be taking. When your students are practicing at home, though, they can type in their name. I'll just type in Coach Brenner, and then we're going to get started. So once we're here, we see that this is a non-calculator section. So that means your students can't use a calculator. The calculator sections will actually provide the calculator on the screen for your students to use. So it's not necessarily they have to use something that's right in their hands, but they could use one at home if it's, or in school, if it's a calculator permitted section of the test. These are the directions that your teacher will read to, your children. And what you would do is you would just hit start here. So here we know that we have different questions. We know that we're going to have 12 questions to maneuver from question to question. Remember, this is just our introduction. I just want you to be able to get onto the website, understand how to access it, and kind of just play around just to get used to it. So here, if we know that we're not sure of this question, one, we can just go to the next question here. Another tool that's up here, if you're not sure, you can just bookmark it. And when you bookmark it, that lets you know when you're finishing up your test, this is one of the questions that you would go back to. But to get to each question, you would hit just this next button. And as you can see, these are all fill in the blanks here. We're not going to get into particular types of questions. Here's a multiple choice. Here's another one where they have to type in different fractions. Here's a drop down. So students have to know how to drop down here. They would have to choose. All right. Their answers. And here, one of the things that students do have to know, especially those third graders, there's a little highlighting tool here. Some of these questions have more than one correct answer. If they only choose one, they cannot get points for it. If it says 2 correct answers, they have to choose the 2 correct ones. All right. So this is just that introduction. We're going through just seeing the type of questions that your students will have to answer and something that they can do. Now, the practice test is the same for anybody that is visiting this website. So once you finish section 1, you can't log back in and get a different practice section 1. So really encourage your students to take their time when they're going through this, especially when they're getting that practice in, to make sure they understand how to do certain things. Now, one thing I do want to go through is one of the tools up here. All right. So our answer eliminator. So let's just look at this particular one. And this is going to help all students out, especially if they're not sure between just two of the particular answers, but they do know that certain ones are wrong. So it says which comparison is true. So this is a perfect one for this. So you click on answer eliminator. One, I'd like to see if they have the same denominators. I know it's a little bit easier for me. So it says which comparison is true. So here I know 3 is greater than 1, right? So 3/6 has to be greater than 1/6. So I'm going to eliminate this one. Also here, 4 is not greater than 5, right? The 5 is greater, so 4/8 is not greater than 5/8, so I can eliminate that one. Now these two questions, these two answers to this question have different denominators. Here it's giving me a 50-50 chance to get it right if I'm not 100% sure just by eliminating these two. So I'm going to come back to that answer eliminator in some of the future MCAT practice review Count on Us videos, but here I just wanted to introduce it on this last question.
Thank you guys for tuning in for today's episode of Count on Us, where we went over how to access the MCAT website, try to maneuver around. We showed where the tutorial is, how to make sure your computer's up to date, along with getting into those practice tests. Now, in the future episodes where we are highlighting the MCAT assessment, we're going to actually dive into some of these test-taking tools, how we can help our students, our children at home. Just like the answer eliminator we looked at today, we're going to be going through different tools and different ways to make sure that we are prepared at home so that our children can do their best. Coach Brenner here. I'll see you guys next time. Thanks for tuning in and have a great day.
4, 3, 2, 1.